This is lesson 4.4, scatter plots and lines of best fit. The essential question here is how can you use a scatter plot and a line of fit to make a conclusion about data? First, you have interpreting scatter plots. A scatter plot is a graph that shows the relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane. Scatter plots can show a trend in data. So looking at example 1 here, we're going to be interpreting a scatter plot. The scatter plot shows the amount X in grams of sugar and the number Y of calories in 10 smoothies. So how many calories are in the smoothie that contains 56 grams of sugar? To do that, you're just going to come over here. You're going to find 56 grams of sugar and go up, and you are going to see that it's got 270 calories. Now, how many grams of sugar are in the smoothie that contains 320 calories? Well, you're going to come over here to the 320, look down, and it's going to be 70 grams of sugar. Now, what tends to happen to the number of calories as the number of grams of sugar increases? Well, if you're looking at this, as the sugar increases, the calories increase. So what you're looking at here is that it tends to increase. So it shows an increase. So when we're identifying correlations between data sets, a correlation is just a relationship between data sets. You can use a scatter plot to describe the correlation between data. If all your points are kind of close together, and as X increases, Y increases, you know you have a positive correlation. You can think of this kind of like your slope. Remember, if you're reading from left to right, if it's going up, you've got a positive slope. So this is a positive correlation. The same would be for the negative correlation. If you're looking from the left to the right, if you're looking down, it has a negative correlation. But if you're looking at the end here, you've got kind of your data points are kind of scattered throughout the graph. There's no real trend that shows whether or not they are going up or down. They're just kind of everywhere. That's when we know that there is no correlation. So how about here in example 2, we're going to be doing identifying correlations. So we're going to tell whether or not the data shows a positive, a negative, or no correlation. Here we have the age and vehicles owned. So if we're looking at the age of a person and the number of vehicles owned, the points really don't show a pattern. The number of vehicles owned does not really depend on the person's age. So the scatter plot shows no correlation. Now, if we're looking at B here, when we're looking at temperature and coat sales, the average daily temperature, as the average daily temperature goes up, coats sold per day decreases. So what we're looking here is, with this scatter plot, it is showing a negative correlation. So using lines of fit to model data. When data shows a positive or a negative correlation, you can model the trend in the data by using what we call a line of fit. A line of fit is a line that's drawn on the scatter plot that is close to most of the data points. To do a line of fit, you're going to make a scatter plot of the data. Decide whether the data can be modeled by a line, and then you're going to draw a line that appears to fit the data closely. There should be approximately as many points above above the line as below it. And then you write an equation using 2 points on the line. The points do not have to represent actual data points, but they must lie on the line of best fit. So the problem here is there can be some variations of the line of best fit. So let's look at example 3 here. We're finding a line of fit. The table shows the weekly sales of a DVD and the number of weeks since its release. We're going to write an equation that models the DVD sales as a function of the number of weeks since its release. So the first thing you're going to do is you're going to want to plot all of these points. After plotting your points, your scatter plot should look something like this. And if you're going to notice, you've got a negative correlation. It is pretty tight there, so it is a strong correlation. You have either a strong correlation or a weak correlation. A strong correlation means that the points are really tight together and almost make a line on their own, whereas a weak correlation, they're a little bit further apart, but they're still showing that correlation. So with this being a pretty compact correlation here, we're going to work on drawing the line of fit here. So now that they're plotted, we're going to decide whether it can be modeled by a line, which yes, it can be. So now we're going to draw a line that appears to fit the data pretty closely. So this is the line that I believe shows a pretty close line of fit here of the strong correlation. Now I've got to figure out the slope here. I'm going to write an equation using the 2 points. I'm going to go ahead and use the points 5, 10 that look like they fall on the line, and 6, 8. It appears that these 2 points fall on that line. So first off, I'm going to find my slope. Remember, change in y, so 8 minus 10, over the change in x, which is going to be 6 minus 5, which is going to give me a slope of negative 2, which does make sense because I said it's a negative correlation, so it's going to have a negative slope. And now we'll use the point 6, 8 here to write that equation. Remember, we can just use our point slope formula. We have y minus my y1, which is 8, equal to negative 2, my slope, times the quantity x minus my x1, which is 6. So simplifying this, we're going to have 8 minus y minus 8 equals negative 2x plus 12. Remember, negative times negative gives you a positive. Add 8 to both sides and you end up with y equal to negative 2x plus 20. So that's going to be your equation of the line of best fit for this scatter plot. Go ahead, get your notes finished up, and get going on your clever assignment.